Good morning once again. It's a lecture on Introduction and Course Outcomes of Crystallography and Optical Mineralogy. This paper has been allotted by Gondwana University, Gadchiroli, to B.Sc Sem 2 students as a paper 2. So, what actually crystallography is? It is a branch of geology that studies with the crystals of various mineral species and their respective properties. Yes, of course, the minerals which we get in the nature, they are usually crystallized in crystals. And definitely those crystals have a definite shape and definite properties. The respective studies of these crystals comes under crystallography. Whereas in optical mineralogy, we are going to study the optical properties of the mineral species. So in the last semester, we have studied the physical properties of the mineral species, whereas in this semester, we will be discussing with the optical properties of the minerals. Both these properties are used for the identification of the mineral. The three units will be of crystallography, whereas the last or the fourth unit will be of optical mineralogy. So, as per Gondwana University Gadchiroli, the crystallography and optical mineralogy has been allotted to B.Sc Sem 2 as paper 2 with a code of USGEOT03. Following is the syllabus of the paper. In Unit 1, we are going to discuss about crystal, space lattice, and unit cell. Crystal structure by X-ray considering unit cell of NaCl, crystallography and geometric symmetry, laws of crystallographies, momentary idea about crystal structures, crystal phases, and etc. We'll also be discussing about crystallographic axes and axis angles, crystal notations like Miller and Rees parameters. So what would be the course outcomes of this unit? Students learns to the basic concept of crystals and respective properties. Yes, in this unit, you are going to learn the basic concepts of the crystals as well as the respective properties of the crystals. At the same time, you will develop a skill to identify the fundamental aspects of the crystals. So after studying this unit, you'll be able to identify the various fundamental aspects like crystallographic axes, angles, interfacial angles, edges, yeah, faces. So you'll be able to identify them in the specimen. You will also develop a skill to measure various aspects of crystals. Like you will be able to measure the, say for example, interfacial angle. Okay, so these things will be the outcomes of this unit. Unit 2. In Unit 2, we are going to discuss about crystal symmetry and classification of crystals into 6 systems. Study of crystals of galena class of cubic system, zircon class of tetragonal system, and barite class of orthorhombic system. Though the unit looks like quite small, but it is not small. It has very broad spectrum. In course outcomes, you can see that you'll be able to understand the concepts of symmetry and the respective criterions in crystals. See, there is a very fundamental concept of symmetry in the crystals, and you'll be dealing with these concepts in this unit. You'll also see how these systems are being classified into 6 crystal systems. You will develop a skill to measure the symmetry elements in the crystals. Yes, of course, the crystals have certain kind of symmetry elements, and after studying this unit, you'll be able to identify these or measure these different symmetry elements. Students learns the isometric, tetragonal, and orthogonal systems of crystals and develop skills to identify them practically. Yes, it is a very important outcome of this unit that you'll be able to you'll learn the isometric, tetragonal, and orthogonal system of crystals, and then you will be able to identify them practically. You'll be given a specimen. You have to identify that to which crystal system that specimen belongs. So you'll develop such kind of skills by studying this unit. So these are the outcomes of Unit 2. Unit 3. Uh, yes, of course, this unit also seems to be quite small, but definitely it has a very wide spectrum. In this, you are going to study the hexagonal system, monoclinic system, and triclinic system. The classes you see here, beryl, gypsum, and axonite, are nothing but the normal classes of this system. Means this classes shows the maximum symmetry of these systems. So what are the course outcomes? Here, you will first learn the hexagonal, monoclinic and triaclinic systems of the crystals, and then you will develop a skill to identify hexagonal, monoclinic and triaclinic system practically. Yes, again, when you will be given a specimen, you will be able to identify to which system the respective specimen belongs. So in Unit 2 and Unit 3, you will be covering all 6 crystal systems, and after completing Unit 3, you will be professionally skilled enough to identify various crystals practically. Unit 4. So now the Unit 3 is the end of crystallography, and in Unit 4, we'll be discussing about the optical properties. So in last semester in paper 2, we have already studied the optical properties, but that was an elementary optics. Now we are going to study here optical properties in much more detail, like the properties under PPL and Cross-Nicoll. These are the arrangements of the microscope. You will find that there are different properties under PPL and Cross-Nicoll. We will be discussing with them. Then optical characters of following rocks means there is a huge list of rocks whose property we are going to discuss in this unit. So what is the course outcomes of this unit? Students learn the fundamentals of optical mineralogy. Yes, though we have already learned them in the semester 1, but in this semester 2, we're also going to have a tangential view over the fundamentals of the optical mineralogy. Later on, you will develop a skill to measure various fundamental optical properties. Okay, you'll be able to understand how the PPL and Cross-Nicoll will work and how to measure the various properties of the minerals. Again, you will learn the optical properties of various minerals. Yes, the list given in the unit, you will be discussing, you will be dealing with these minerals with respect to their optical properties, and you will learn them thoroughly. Then you will develop a skill to identify the mineral on the behalf of optical property. Yes, this is a very important and crucial outcome of this unit, that after completing this unit, you will be able to identify different minerals on the basis of optical properties. In a similarly, when we studied physical properties, you were be able to identify them on the basis of physical properties. Similarly, in this unit, you are going to identify different minerals on the behalf of optical properties. So usually, what a mineralogist do, a mineralogist derives conclusion from both the properties, means from physical properties and from optical properties too, and combinedly he can conclude the name of that respective mineral. So usually we won't conclude the mineral on the behalf of only physical properties. We also supplement the our inference or our conclusion with the optical properties. And for more detailing, you can go for the chemical analysis. But for your say for example for your kind of caliber, the optical properties are much enough for now. Now let us see the summary of the outcomes. So when you will study this paper, and at the end of this paper, you will find that you would have developed such kind of skills. The first is you'll be able to understand the basic crystal structures and will develop various concepts of the crystals. Yes, you'll develop understanding towards the various concepts of the crystals and their respective structures and properties. Students develop skills to classify the mineral into various crystal systems. Yes, this is a very important aspect where you will be able to classify the different minerals into 6 crystal systems. Okay, you can find whether to which the respective mineral belongs to which crystal system. Okay, this is a kind of a professional skill you will develop at the end of this paper. You will also develop the skill to identify the minerals on the basis of crystal shapes. Yes, on the basis of crystal shapes, on the basis of different properties, you will be able to identify minerals, and accordingly, you can supplement this data in your Conclusions. You will understand the basic optical behavior of the minerals and develop a skill for their identification on the basis of optical property. This is a very important and a crucial outcome of this paper, where you will learn about the optical behavior of the minerals and simultaneously will be able to identify various mineral species on the basis of their optical properties. So this was all about the introduction and the course outcome of this paper. I am very thankful for your patience listening.